So we're going to be continuing our work with implicit functions. Today we're going to find out how to do the second derivative of an implicit function and then also find the tangent line of an implicit function. So let's go ahead and write down example 1 here. Okay. Well, the first step, guys, is to find the first derivative. So I'm going to let you guys go ahead and do that. Find the first derivative for me. I'm going to let you guys do the work. Go for it. Derivative. A lot of you guys got this far, and then you thought you were done. But you weren't, right? But then I did see a couple who are having trouble getting the y prime by itself. So minus the 8x is first. Then divide both sides by 6y. And so here's your answer, but we can reduce it. And so here's a better answer. So that's your first derivative. Now we want to find the second derivative, right? So if I want to find the second derivative, first thing, what I'm going to do is I'm going to put that in brackets, and we're going to write this again, right? So first of all, if you take the derivative of y prime, what do you get? You get y prime prime, y double prime. Okay? Now this guy over here, how do you take the derivative of this thing? It's the quotient rule. Haven't seen that in a little while. So low d high minus high d low. What's d low? 3y prime. Draw a line and square below. Right? All right, let's simplify that. So after you take the second derivative, you want to simplify it a little bit. And I would write these steps down because you're gonna. I'll show you why we're not done yet. It may seem like we're done, but there's a little bit more to go here. Y double prime is equal to, what's this going to be? Negative 12y. I'm just multiplying them. And this one here, what's this going to be? Minus a negative 4x 3y prime. It's going to become a plus because of the double negatives, and then a 12xy prime, right? Over (9y squared). Okay, so that's as simplified as it gets. But now here's where things get a little bit interesting. They don't want you, typically, they don't want you to leave this there. Okay? They don't want a y prime in the solution. They want just x's and just y's. So what does y prime equal? It equals this, right? And that has just x's and y's in it, right? That's what we need to put over here. So that's kind of like the aha for this problem, is that you have to actually, it's not so much just finding the derivative. You guys have some experience with that. The new thing that you probably didn't realize is that you have to take that y prime and you have to replace it with what y prime is. Okay? So that's kind of the thing you really want to star there. So we had negative 12y, right, plus 12x y prime over 9y squared, and we're putting in there negative 4x over 3y. Is that right? Okay, so I would star that, and I'd say, that's the main step there. We want to replace y prime with, and I'll draw the arrow because that's what y prime equals, right? And that's y double prime. And free response. I've never seen a free response question like this, but you probably just want to leave it. But multiple choice, I have seen multiple choice questions like this. You need to know how to simplify it. Okay, so first of all, what would you guys say we need to do to simplify this? So I'm being suggested that we should probably multiply these. Okay, I can go that way. What would that give me? 4x.
If you put it over 12x over 1, can't you just use 3?
Oh, reduce these?
Yeah, reduce that.
Okay. Yeah, you can do that. Sure. So this is like a top number. This is like a bottom number, right? So we can do 3 into 12 how many times? 4 times. And then we multiply straight across, right? So what's 4 times negative 4x? And what is 1 times y? 1y, right? Over 9y squared. What do you guys suggest now for simplifying this? And what about the y's? Cancel the y's? Okay. What were you saying, Graydon?
So I was saying adding the negative 4y.
You could do that. That would work. Any other thoughts? Yeah? Well, so here's what I agree with you on that one, is that you are allowed to multiply something on the top and bottom, right? So if you want to multiply the top by 9y squared, for instance, you can, so long as you also do it to the bottom. And that's kind of moving closer to the strategy I would suggest to you guys. Okay, so now the reason why I wanted to get your guys' opinions first is because you guys do have some algebra skills to bring to the table, and whatever you're comfortable with, I encourage you to maybe go with that. But here's how I handle these, and this would be my suggestion. So Graydon, like your suggestion of adding, that'll work. You have more aspect to do, but it'll work. Here's what I would do. What piece of this do you wish just didn't exist right now? You wish this wasn't here, huh? Right? What's a way to get rid of that? Yeah. I'm going to multiply this by y. But when you multiply this by y, you got to multiply the whole top by y. So now I'm going to multiply this by y also. And whatever you do to the top, you need to do to the bottom. Okay, now what happens when you have y over 1, right, times something over y? The y's cancel. So that's my suggestion to you, is to find that piece you don't like and multiply every term by that number, and that will cancel that out. And so what we're left with then at that point is we're left with negative 12y squared minus 16x over 9y cubed. So after that, I'm going to call this step clear the fraction, however you want to do it, but I'm showing you my strategy. Clear the fraction now, if there is one. There may not be one, but it's not uncommon for it to be there. And then we go ahead and we simplify, right? All right, but we may not be done. This may be able to be reduced. Does anything factor out of the top? What? 4 does. No, this one doesn't have a y on the top, so I can't take a y out. But I can take out a 4. So that would leave negative 3y squared minus 4x, right? And we can't really factor the bottom. Does that really reduce anything on the bottom? No. So this is fine. This is also okay, but my guess is they would probably leave it like this. But you probably should see if it can be factored and reduced, right? All right, so here's the big aha, right? It's this thing. Just find the derivatives like normal, but don't forget to replace the y prime with what y prime equals. That's the big step for today. The rest of it is just muddling through algebra, okay?
Could you, do
12 and 9, not separately. They have to be together. So if you reduce something out of the 12 with the 9, it has to go with the 16 as well. All right, so let's throw in at you guys here. Go for it. Show me what you got. I'm going to start going over this. And then the first derivative I'm not going to spend too much time on. I feel like you guys probably have that down fairly well. So Neha, what did you get for your first derivative though? Okay, so that's correct. That's your first derivative. Now we got to find the second derivative. So we take the derivative of the derivative, right? At that point, Vivian, what would I get if I took the derivative of the derivative? What's the first thing I would write here? So we're taking the derivative of the derivative. So what would you get first? Uh-huh. Uh-huh. Oh, sorry, yeah. I'm just catching up with you. Okay, minus
9x squared.
Uh-huh.
And then 10y prime.
Good. I did have a few people that forgot their y prime here. Don't forget, anytime you take the derivative of something with a y, you get a y prime. All right, and on the bottom?
10y squared.
Okay. Now I'm going to stick to my steps here. In my steps, the next thing was simplifying. So, John V, what would this be if I did all my multiplication? Don't I leave what? We can simplify this. So like for instance, what would 10y times 18x be? 180 what? xy, right?
So it's just
Minus?
if you put a 1, that shows it's a crop, which is something.
Did you say 90? Okay, 90x squared y prime. And how about on the bottom?
Just to mark out, so you know that was the end of a prime.
100y squared.
So that's a prime.
Okay. Now, some of you guys chose to reduce at this step, which is fine. You can. Like I could divide all 3 of those by 10 right now. I'm not going to. I'm just going to stick to my steps and do it at the end. But you can. All right, next. The reason I don't want to do that is because after I do more changes, I might have to reduce again anyway. So I just like to leave that till the end personally. But all right, so Chris, what do I do now? That's right. We're going to replace that y prime with something. What do we replace it with, Chris?
What did you say?
What do we replace it with?
9x squared.
Thank you. All right. Now we get to simplify. So I'm going to ask Julia, what do we do first to simplify this?
Because remember, since there's no exponent there, since
I
there's exponent, that becomes 0.
I like stuff like that step, but I don't like fractions, so I would want to get rid of that.
That's just gone.
So you would start by doing what then?
Oh, for the x.
Yes.
It
The
multiplied
x disappears and then just the 3.
You could do that. So Julia didn't want to do what Mateo told us to do earlier. Mateo said to do the 10 into the 90 first, which you can do that. But Julia just wants to get rid of the bottom now, and that's fine, that'll work. So Julia would just start by multiplying everything by 10y in the beginning. The downside is if you don't reduce first, you get bigger numbers. So your reducing gets a little bit heavier at the end, but it doesn't really matter. But I'm going to stick with what we did last time just so we don't confuse people. But yes, what you said will work. So 10 goes into 90 9 times. Okay, so now I've got 9x squared times 9x squared. What would that be? 81 x to the 4th, right? But I still have a y on the bottom there. And so now I'm going to do what Julia said. I'm going to get rid of that y. I'm going to multiply everything by y. That way these go away. Okay, so that leaves me with 180x y squared minus 81 x to the 4th over 100 y cubed. Are we good? Okay, now what can I factor out of the top here? 9. And will 9 reduce with 100? No, so I'm not going to bother factoring then. I don't think anything. Oh, wait. Oh, we also could have factored an x out, right, you guys? Don't they both have an x? But will that take anything out on the bottom? I'm not going to worry about it again. But you do want to watch out for variables. Sometimes you could take a variable out too, okay, when you reduce. All right, I don't think anything reduces here, though. I think we're good. So there's your final answer. That's the second derivative. Well, you can. I'll show you what you get. So if you actually wanted to factor it, you erased it? You will write it again, Graydon. All right, so I could take a 9 out, right? And what else, Angelina? Yeah. Don't you guys all wish you could just take your x out? No? All right. So if I divide 9 out, I get 20 y squared minus 9x cubed, right? Now in this case, 9 and x, neither one of those are going to reduce with the bottom, so there's kind of no point in doing that. And so the answer you would see on a multiple choice test more than likely would be this one, the original. All right, so that's the second derivative. Let's do a tangent line. Write her down. All right, so how do you find a tangent line? What? You find the slope and you find the y value, right? After that, we plug it into here. So John, I don't know if you want to, I appreciate your diligent work there. I don't know if you want to get this or not. We're finding the tangent line of an implicit function now. So, okay, whatever you prefer. All right, so here you go. So my next question is, how do you find the slope of a function in calculus? Derivative, and then plug in x. Okay. How do you find the y? Plug it into the original. Okay, so now this is where implicit functions are a little bit different. Okay. What do I usually do first? X, m or y? I usually do m first. But with implicit functions, you want to start here. Because when you have an implicit function, like your derivative, right? Look at your derivative from the last problem we did. What was the first derivative? The one we just did.
It's like a rig. 9x squared over 10.
It was 9x squared over 10y. What do you notice about your derivative? It has an x and a y. So you're not going to be able to find your slope until you have the y. Does that make sense? So when it comes to implicit functions, you need to find your y value first. Then we'll come back to this and do our slope. So let's find our y value. It's going to be 3 equals x. What's the x value? 1 plus 2y cubed. All right, 1y cubed is 1. I'm sorry, 1 cubed is 1. Subtract 1 on both sides. Divide. And what does y equal? 1. So we have our y value. X is 1, y is 1. So step 1, with an implicit function, and you could always do that for all. You could always just find the y first. And that way you don't have to really make yourself think anymore and do something different. Just on every problem, just always have the y. And in case you guys haven't noticed from the homework and the FRQs that I give you, sometimes they just give you the y value, right? So you don't have to find it. Like some of your FRQs you have for this weekend, they just give you the y value, so you don't have to do that. All right? Okay, let's go ahead and do our slope. So now we get to do the derivative. I'm going to let you guys find the derivative. So I'm going to pause my video here and let you guys go ahead and find me my derivative real quick. So here's our first derivative. You may have reduced it and gotten this. Either way is fine. Now, usually when we want to find our slope, what's the next thing we do? We plug in x, right? But this is an implicit function. So you need to plug in x and y. So my slope then is going to be negative x squared over 2y squared. What do I plug in for x? 1. So I'm going to circle that. I'm going to draw an arrow here. And then what do I plug in for y? Now the reason I'm drawing arrows is for your guys' notes. I want you to understand we didn't just plug the same number into both blanks. We plugged x in for x and we plugged y in for y. The reason why it looks like we plugged in the same thing is because they are the same thing in this case. But a lot of times your y value will be different, okay? So just know that the y value goes where the y is, the x goes where the x is. And what does that simplify into? Negative 1/2. Notice the negative does not cancel. So Andrew and Angela, did you guys have a negative on your slope? Well, we're not squaring the negative though, just for 1. So it should be a negative. I don't remember if you guys said it was negative or not, but there you go. All right, from there, guys, we have our answer. What's my y value? What's my slope? And x value? We'll stop while we're ahead. Okay? So, 2 differences when it comes to finding the tangent line of a implicit function. One difference is make sure you start with y. Second difference is when you plug in, you have to plug in x and y to find your slope. All right? I'll give you guys a student practice, and that'll close us out for the day. So, yes.